Hello, everyone. Thanks for joining the session today. Topic will be related to reducing food deserts with the Internet of Things. My name's Ali Hosseini. I'm the Chief Executive Officer and founder of Toyo, which is a Charlotte-based IoT tech startup. Those that know me may also know that I'm the CEO and founder of Cinra, which is an IoT network operator based out of India. At the end of the presentation, there won't be a Q&A, so if you have any questions that you'd like to direct directly to me, you'll see my handles and social media down here. Feel free to reach out anytime, DM me, and I'll try to get back to you as quickly as I can. What you'll see today in this presentation is basically an explanation on what food deserts are, and I'll try to kind of explain the root cause, how we can try to address food deserts in general, and then I'll transition that into the Internet of Things, provide a brief description of what that is for those that aren't familiar, and then transition into how that came into play on addressing something as critical as food deserts. So what is a food desert? A food desert is an area where people have very limited access to healthy, affordable food. Somebody living in a food desert faces daily obstacles, preventing them from going to a grocery store and buying fresh, nutritious foods like fruits and vegetables. The USDA identifies two types of food deserts, and it's kind of divvied up between urban and rural areas, as well as the proximity to the closest grocery store. So their definition is low-income urban areas where a significant number of people live farther than a mile away from the nearest grocery store. And in rural areas, it's low-income rural areas where people live more than 10 miles away from the nearest grocery store. So the USDA estimates about 19 million residents in the US live in food deserts. That's approximately 6.1% of the population, which is quite large. What causes a food desert? There's around four main things, if you do your research or Google online, that you'll see that contributes to the definition of food desert or the issue. One is the income level. That is typically an impact in areas of cities where income is at the lowest. Also, unreliable public transportation or the inability to get easy access to grocery stores within those low-income areas. And one of the big problems that they reason the definition food desert comes from is the fact that there's no grocery stores in those areas. So the locations of the grocery stores not being close to these low-income neighborhoods creates a big issue for the local community. And the underlying current which created all of this is really racial segregation. So what I've done since the project that I'll be talking about is in Charlotte, North Carolina, I pulled some data from the Quality of Life Explorer for Charlotte, Mecklenburg County, and you'll see four maps and graphs that depict what food desert and why it's there and where it's located within the county. On the top left, you'll see the grocery store proximity issues. The lighter greens depict where there's less grocery stores, and the darker colors are where grocery stores are prevalent. And I've highlighted in red where the biggest issues within Mecklenburg County are in relation to food deserts. And the reason those areas are only highlighted red is because if you look to the right, the household income in those areas are at the lowest scale in regards to the overall county. And the interesting correlation is that those areas are predominantly Black or African American, Hispanic or Latino ethnicities within those neighborhoods. So the project that we worked on in Charlotte was to pick a location within these food desert areas and try to solve the problem to bring healthy food to the local neighborhood and community. So how can we eliminate food deserts in general? There's three things that we can do. I'm sure there's more, but I wanted to highlight on these that have been taking place throughout the country in an attempt to reduce food deserts. One is creating community gardens. Many residents of food deserts have increased their access to fresh, healthy produce by growing it themselves and distributing it to their neighbors. The project I'll talk about and how we used IoT to support that effort is actually a community garden. And the image you see to the right here is in the beginning when we started building out the boxes for the community garden. Other things that you can do to help eliminate food deserts is co-ops. We're seeing in cities local residents combating food deserts by opening up their own collectively owned and operated markets to bring those healthy produce and fresh fruits to the neighborhoods of need. And then we're also seeing some areas where the corner store owners, the bodegas, they're actually stocking their shelves with healthier options of fruits and vegetables instead of these processed meals and junk food. And so by leveraging all of this, you can start to chip away at the issues of there not being easy access to healthy food in these low-income neighborhoods. So you probably ask yourself, now that I know what food desert is, how does the Internet of Things come into play? Well, let me define what the Internet of Things is first. For those that have never heard of it, it describes a system where the Internet is connected to the physical world via ubiquitous sensors. Over the years, IoT evolved from really simple computing and short-range wireless communications to now powerful data processing and the ability to monitor and control these objects or sensors from very long distances with minimal to no human intervention. Why that is important is that we had some challenges and constraints in the garden where we needed to find a way to address some resourcing issues. And I'll talk a little bit more about that here on the next few slides. But some of the top benefits of the Internet of Things are listed here that I thought I would want to share with you all before I jumped into the case study. And that is, one, reducing project timelines and money. Two, IoT enables faster business decision making. Three, it enables competitive advantage with new business models. This one specifically really helped us in our project, which is enabling predictive maintenance, leveraging sensors and software to be able to get ahead of things before the issues fester and get worse. And then improved processes and systems, the increased visibility on day-to-day operations, and overall with the Internet of Things, some of the most important things for a lot of companies and entities out there is the improved customer experience. So the case study that I'll talk about was actually located in Charlotte, North Carolina, to the west part of Charlotte, if you were to remember the map, in one of the highlighted red circles. It's actually located at Shiloh International Baptist Church. We've got a beautiful sign now after a few seasons of doing the gardening that is there, which I took a picture of and put it here for the presentation for you all to see. What we did with the Internet of Things was to tackle some challenges we faced right off the bat when we started doing the gardening and setting up this entire edible landscape and orchard. And the technology enabled us to do crop monitoring, and it automated our irrigation system, which had a huge positive impact on our output and productivity of the garden. So the challenges that we faced are listed here. One, it was a nightmare, to be honest, to try to coordinate volunteers for watering the garden and keeping that going on a regular basis. During the hot season, which we started this right at the end of spring last year, these crops needed to be watered almost daily in order to give them enough water to grow and produce healthy produce. So that was a huge issue. Being in a low-income neighborhood, a lot of these families are working 2 jobs just to be able to provide food for their families. There was a lot of senior citizens and disabled people within the community that was difficult and challenging for them to come out on a regular basis. So what we wanted to do was find a way to enable the neighbors and the community to learn and be educated on how to create healthy food, but not take away from their day-to-day activities and kind of push them away from the whole concept. So we had to find a way to tackle the resource constraint. The other thing was is we really didn't know when the watering was taking place, if we were overwatering or if we were underwatering, which was leading to sometimes crops dying because of the lack of water, and as well as just wastage of water due to overwatering. So we needed to find a way to not only handle the resource problem, but we also needed to be able to handle the water and make sure that it was efficiently being used at the garden. And the challenge with these two led to massive decrease in productivity or production of the crops at our end of our first harvest, which was quite disappointing because we were really looking forward to having healthy food that we could distribute into the local neighborhood. So being the IoT guy that I am, I pulled in technology. My expertise comes many years within the LoRaWAN space, which is a low power wide area network technology. We were unable to use short distance range communications on this project because of the location of where the internet was accessible for the router, or what we call in LoRaWAN space gateways, to where the garden was residing and where the sensors would need to be deployed. So I immediately thought that this low power wide area network technology would be a perfect fit for this use case. What we did is we brought in some sensors. Actually, out of 7 garden boxes that we had at this community, we only needed one soil moisture sensor, where we installed into one of the boxes. You'll see in the image, there's 2 probes that the sensor has, and you stick them directly into the soil. It transmits a frequency between the 2 probes and sends that frequency data to the cloud into our analytics platform to do processing. And using algorithms and software, we're able to convert those frequencies into soil moisture levels, which then enable us to know, okay, is the soil too dry or wet or just perfect? So with the soil moisture sensor being installed in the box, we got a really affordable router or gateway, installed it inside the church, connected it to the internet, and then routed the data from the sensor to the cloud into our application server, where we were able to decode the information and start making sense of it. We also put a sensor that was connected directly to a water valve to turn on or off the water based on the sensing of the soil moisture. And I'll go in a little bit more detail on the next slide. So you can see it here. It's kind of simple from a graphic perspective, but it's a lot going on in the background. Is the soil moisture would send the data to the gateway. The gateway would route the data to the application server. The application server would send the data to, would send a notification or a message to the smart emitter device saying, hey, there's something wrong, please turn on the water. So these are images of the actual devices. Soil moisture and temperature monitoring was done with the soil sensor up here in the top right. We provided a really straightforward and easy to deploy solution, which monitored the soil moisture, soil temperature, the air temperature, and the humidity. And we took all that data, put it in the server, and we're able to monitor it over time and in real time. The objective was to increase the crop yields and decrease the operational expenses by having direct insight on the crop growing environment. And then on the other side, where the valve resided, so this is not a smart device. This right here is just a valve that you can get from your local home improvement store. It typically is connected, if you're using a solenoid with a wire, it'll be connected to a timed base solution that's out there that you can buy off the shelf. However, we wanted to take it to the next level and not set up an irrigation system purely off of timing, because we wanted to try to increase as much water savings as possible. And if it's raining outside, you don't really need the water to turn on. So when their soil moisture is fine, the water doesn't need to be flowing, but when it's starting to dry out, it does. So this device here, this little white box, we call it a smart emitter. The wires connect directly to the solenoid, and as soon as a message is received from the cloud or our application server to this smart emitter, it will send a pulse, a surge through the wire to then open or close that valve of the water flow. So we remove the need for traditional watering methods by leveraging a wireless time control emitter designed to provide long-range wireless capabilities to irrigation and sprinkler valves. The smart emitter connected directly to the DC latching solenoid of an irrigation valve, allowing us to automate the valve's open-close function based on environmental variables, specifically the soil moisture. These are some videos that I've recorded just to kind of walk you through on how the setup took place. The first one on the left is the picture of the actual smart emitter. We had to put it in connection with a solar panel, where the reason being is this device, if you know LoRaWAN, it's a Class C device and it consumes a lot of battery when it's running. So we wanted to find a way to extend the battery life as much as possible. So we connected it to a solar panel where during the daytime, it was taking external power directly from the sun. And at nighttime, it would then switch to using the battery. And we extended the battery exponentially by doing this. So you'll see that and how that was set up. We had to use a DC, a buck converter to downgrade the current that we were receiving from the sun so that it didn't fry the circuit board on the smart emitter. And then you'll also see how the wire is connected to the valve and then ultimately the water system. So the camera will zoom in, you'll see the valve. The back of the solar panel has the buck converter that is connected to the solenoid. The solenoid wire runs down to the ground where the valve is. Here, I'll just pause real quick. This is not installed yet. This was done during the testing phase, but you'll see the PVC pipe is connected and the water flows from left to right. The solenoid is on top of the valve, and then we tied the wires of the smart emitter directly to the solenoid. So when that message is received from the cloud, it'll open or close the water accordingly. We also are able to manually override that automated process of the soil moisture directly from the system by just a press of a button. So initially we wanted to use PVC pipes to provide the water to the system, and it was working just fine. You can see images of the water flow coming into the garden. However, it was coming out too fast and we were not getting the water savings that we wanted. So what we ended up doing is switching the PVC pipe to a drip line pipe, which you can get from any local home improvement store. And what this is called is a micro irrigation technique. So after we switched it, you'll actually see that it has a very slow drip, and it was optimizing the water usage. So after doing this, the water wastage reduced drastically. We had about 90 to 95% water savings once we finally had the irrigation system working fully automated with the drip line. This is another video that shows after some crop growth has taken place and the drip irrigation line receiving the water from the water system. You can see here, this is collard greens that we were growing, and it's about the end of its season, so we're going to be ripping these out soon. We have finished 3 seasons right now, and we're moving into season 4, and we're going to be planting some really cool summer crops coming up. So the project results was a massive success. We had great water savings because of the micro irrigation technique. We ended up having higher quality crops that we were able to harvest, and we started having such a surplus that the surplus was then distributed to Loaves and Fishes, which is a local nonprofit organization, where then they took that food and distributed it to other neighborhoods in need. All of this we were able to do with our provide real-time analytics and insight on these environmental variables, and it was accessible from a mobile application for the stakeholders, as well as a web app, so they could log in on their computer or access it from the phone to be able to see what was going on throughout the week or months that the garden is running. And I think the most important thing for me is we were able to give time back to the volunteers. So there was less time that was needed to be spent on a daily basis at the garden. And this really is key here because volunteering shouldn't be a job. It should be something that enables you to be passionate about something and to give you the ability to learn. And by reducing the need of people to be there on a daily basis, volunteering actually went up. We now have more people contributing their time because it's not as much of a commitment, and the education and knowledge transfer is starting to take place. At the end of the day, this garden is not meant to supply crops for everybody. It's really a platform, in my opinion, to enable people to learn how to create their own healthy environments and produce their own healthy food. So at the end of the day, we're successful if we've got one or two neighbor families starting to do this in their backyard. And over time, not only are they getting healthy food, but we're creating more green space, which will help with the pollution levels and ultimately create a better planet. So we couldn't have done any of this without our local partnerships. I'm really thankful for having the opportunity to contribute to this. Our Mecklenburg County Public Health Department really came together and pulled all of these organizations together with obviously Shiloh Institutional Baptist Church, which provided some of their land to put the garden. Loaves and Fishes helping us to distribute things, and then the local community themselves, the Camp Green Neighborhood Association, bringing in the volunteers. And then the Shiloh Institutional Baptist Church also was able to reach out to the United Way, the Village Heartbeat, to bring in more and more volunteers throughout the seasons to come help maintain and keep the garden running. So thank you to all the local partnerships. And really what we're doing, or what we're trying to do, is connect our community, bringing tech and using it for the good. The Internet of Things really has powerful things that you can do with it. And this is just one example that I've shown you all today. I hope it has given you guys some insight and maybe some aha moments on things you can do in your own local neighborhoods. And I really thank all of you for taking the time to listen to my presentation today. If you have any questions or you want to reach out to us and learn more, our email address and website are listed down below. And again, thank you all for this wonderful session.